McIntosh, and I'm here again for podcast number 2 for Professor Lewis's Calculus 1 class. And I worked by myself on this one, so I may have less problems than the rest of you guys who may see this video. But anyways, let's get started. I got 2 from every section. So we're going to start off with 3.5. I want you to look at number 5 and number 12. And we're going to start off with number 5. Number 5, the problem says, it wants you to find the derivative of y equals cosecant x minus 4 radical x plus 7. Now, the main thing we're going to be doing on this function, finding the derivative of this function, is we're going to be using the power rule. So what I did is I wrote out, the problem first, and then I did y prime equals the derivative of cosecant x minus 4 radical x plus 7. Now, what you want to do now is find the derivative of cosecant x, which is negative cosecant x, times cotangent x. Now, I'm going to move back onto the radical, but first we're going to move on to that 7. 7 is a constant, so that's automatically going to be a 0. So for that radical though, what you're going to want to do is you're going to take that 4, or any number that's outside that radical, and put it inside the radical as a fraction. So there's no number next to x, so automatically x is going to be 1. It's going to be to the first power. So what that's going to turn out to be is x to the 1/4, and that will break the radical as it is, because we're not trying to find the quad or tetra root, whatever you want to call it. But anyways, so now you got y prime equals negative cosecant x times cotangent x minus x to the 1/4. However, we're not done, because we need to find the derivative of x to the 1/4. Use the power rule yet again. Multiply 1/4 times x and subtract it by 4/4, which is also 1, and you get 1/4 x minus 1/4 x to the negative 3/4. So the entire thing will end up be looking like negative cosecant x times cotangent x minus 1/4 x to the negative 3/4. For the next problem, we're going to mainly be using the quotient rule, and these are all trig functions, so I trust that these are kind of simple, very easy. The problem says y equals cosine x divided by 1 plus sine x, and automatically you're going to want to use the quotient rule because you got variable on the top and the bottom. So low d high, high d low, y prime equals 1 plus sine x times the derivative of cosine x minus cosine x times the derivative of 1 plus sine x all over 1 plus sine x squared. The derivative of cosine x is negative sine x, and the derivative of sine x is cosine x. My bad. For a second I got mixed up. Anyways, so it's going to end up looking at 1 plus sine x times negative sine x minus cosine x times cosine x. And you're going to combine like terms, and you're going to get 1 minus sine squared x minus cosine squared x. And you keep the 1 plus sine x squared. Alright, so moving on to 3.6, this is a section of chain rules. And basically, if you have more than one x going on in a function on the same side, you're not multiplying it, that's where you're going to use the chain rule. So 13, it's y equals x to the second over 8 plus x minus 1 over x all to the 4th. And what you're gonna do is you cover up that first, take the exponent, put it in front of the function right there, and then you're going to subtract it like you do in the power rule, and you get 3, and you put that on the right side, and then everything that you had in that top function, you're gonna bring it all the way back down. Now that you got that part, you got to find the derivative of what's on the inside. Alright, so you're going to find the derivative of x to the second over 8 plus 1 plus 1 over x. X to the second over 8 is 2x to the 8th. 1, the derivative of 1, well, you can't find the derivative of 1, that's actually 0. But anyways, and to get the derivative of 1 over x, you would have to put x on the numerator, which would make it 1x to the negative first. The derivative of x to the negative first is x to the negative second. And your whole problem is going to end up looking like y prime equals 4 times x to the second over 8 plus x minus 1 over x to the third times 2x over 8 plus 1 plus x to the negative second. Now for number 21, it's y equals e to the 5 minus 7x. Yeah, I don't know how to say that properly. And another chain rule. This one's fairly simple again. Y prime equals e to the 5 minus 7x. You're going to basically take that because e stays the same and just find the derivative of what you have as your exponent. So 5 minus 7x, and 5 is a constant, so that's automatically 0. And x is 1. 1 times negative 7 will mean it's negative 7. So you get y prime equals e to the 5th minus 7x times negative 7. You just bring that negative 7 to the front, and you get y prime equals negative 7e to the 5 minus 7x. My name is Harris. Now for 3.8, you got two problems again. In this one, you got the power rule and the product rule. And the question is, y equals x to the 4th over 4 times the natural log of x minus x to the 4th over 16. Now, set it up. Y prime equals the derivative of x to the 4th over 4 times the natural log of x minus x to the 4th over 16. Now, you could already find the x to the 4th over 16, and that's 4x to the to the 3rd over 16. And you could simplify that again, which I did on here, and you get x to the 3rd over 4, because 4 into 16 is 4, and they cancel out on the x side, on the numerator. But however, for the x to the 4th over 4 and the natural log of x, you'll have to use the product rule because you're multiplying those two variables. So you'll get y prime equals x to the 4th times the derivative of natural log of x plus natural log of x times the derivative of x to the 4th over 4. Write that down. The next part, you get y prime equals x to the 4th times 1x, which is the derivative of natural log of x, plus natural log of x times 4x to the 3rd, which is the derivative of x to the 4th, all over 4. You're going to simplify all this, and it's going to leave you with y prime equals x to the 3rd times natural log of x plus 1 over 4. Once you get that, you can go ahead, simplify again, like terms and all that. You could take out the denominator. Dang, I forgot what part this. And basically, the one is going to be canceled out again, and that leaves you with x to the 3rd times natural log of x. Sorry, I didn't explain that one that well. My bad. And now finally for 29, this is another chain rule except with natural logs. It's y equals the natural log of x. So what you're going to do first, you're going to find the derivative real quick, and that's going to give you 1 over the natural log of x. Once you got that, you want to find the derivative of what was inside the parentheses. So that would be natural log of x. So it would be y prime equals 1 over the natural log of x times the derivative of natural log of x. And the derivative of natural log of x is 1 over x. So it's going to be y prime equals 1 over the natural log of x times 1 over x. And once you get all that, that would end up being combine like terms, and that would end up being a y prime equals 1 over x times 1 1 over x to the natural log of x. My bad. I don't know why I couldn't say that. But anyways, that's what I have to explain. I hope you understood what I said. I might have gone this a little bit fast, whatever. I enjoy, being in class with you guys. Thanks for watching. Have a nice day, good night, safe dreams, and do whatever you have to do. Alright.